Well, I just spent 10 minutes and we do a quick review because I'm having a hard time getting any feedback back here. How far are we going back? All right. Are we okay picking which one is the null hypothesis, which one is the alternative hypothesis? Yes.
No has to be 0, right?
No, nulls has to be equal. So we have, first step is we take the claim, we state it symbolically, yes? And then we assigned null hypothesis to either the claim or the opposite, whichever one has the equal sign, right? So all right, so let's do this. So far, so good. We state the claim symbolically, we state the opposite. Symbolically, H sub 0 states that population parameter is equal to some value, right? Okay. So far, so good. Next one, we assume the null hypothesis, H sub 0, is true. And after we assume it's true, we're going after it with claws and teeth. And what we're going to do with it is we're going to try to reject it. If we have enough evidence to reject H sub 0, we're going to prove H sub 1 right. Option number 2 is we fail to reject H sub 0 and do nothing to H sub 1. So far, everybody's with me. Okay. Next thing is we want to be able to say something about H sub 0, right? We cannot prove it right, but we can prove it wrong. We can reject it. If we reject H sub 0, we cannot do it the way politicians do it with 100% sure, right? We know that in statistics, when we're dealing with samples out of a population, those samples hopefully are taken or must be taken randomly, yes? And after they're taken randomly, they will reflect the population. Will they reflect the population perfectly? No. No. So we need to allow ourselves some wiggle room, right? But if a sample is taken randomly, it should reflect the population pretty well. Yes? Yeah. And the bigger the sample, that should reflect the population even better. Yes. So what we introduced last time, according to my notes, is that to make a decision if we are going to reject H sub 0 or H sub 1, we have a couple terms. One of those terms is significance level. So significance symbolized by alpha. And significance level allows us to, significance level. So significance level allows us to produce a critical value and we define a critical value as a value that separates, so critical value separates the reject region, rejection, significance level alpha gives us a critical value, and the critical value separates the rejection region from the fail to reject region. So far, everybody is good. How do we do it? Well, we did it before. So for alpha 0.05, we have a critical value so far, so good. Yes, we know how to do this. We did this before. Just before that, we started with confidence level, we got alpha, and then we calculated. That's right. All right. Any questions so far? No. Okay. So what's a rejection region? Rejection region is a part of our graph, right? Part of our distribution, that when the test statistic lands in the rejection region, we reject the null hypothesis. So if the test statistics falls into the region, we reject H sub 0. So far, is everybody caught up? Okay, good. Now,
one question.
Yes.
If we reject it, doesn't it already prove that it is H1 is right?
if we reject H sub 0, we prove H1 right, yes. But we don't know, right? When we start, you don't know. You start with assuming H sub 0 is right. It's true. You start with H sub 0 being true. Then you follow certain steps of a procedure and you try to disprove H sub 0. If you succeed at proving that H sub 0 is wrong, we assume that the opposite of it is right. If there are two people in a room and one of them is a murderer, if you can prove one of them guilty, the other one is innocent, right? The other option is we can fail to reject H sub 0. We don't have enough evidence. The sample doesn't prove that the statement about the population is wrong. And this is the moment where we do nothing to H sub 1, because just because you proved one of them not guilty doesn't mean the other one is guilty. Not guilty doesn't mean innocent, right? So fail to reject doesn't mean you proved it right. Okay? So this was the beginning. And if I remember correctly, we drew a small picture in class, but just in case we didn't. Can I cover this? All right. So here's the three cases which we have. We have case number 1, case number 2, case number 3, right? Because the example we did was this. We did this survey, a sample of 706 CEOs found that 61% were male. Claim is most CEOs are male. That was this. And we got some test statistics and we got some critical value, and we're going to deal with, I'm going to do this example again from scratch. But before we do that, let's talk about the rejection region. Where do we find the rejection region? Okay. So we have 3 cases. In each one of those cases, sorry?
You said the rejection region?
Yeah, we're looking for the rejection region. So we have 3 cases. Now, where do we find the rejection? We have this alpha produces a critical value for us. Yes? Yes. How does it produce? Alpha is an area, is a probability. Yes? In case number 1, we look for the rejection region here. This is the rejection region. How big is this rejection region? Well, it's based how big, not what critical value, how big. Well, it's alpha big. In our case, 0.05. So what's the critical value? Well, if we know the area for this space, we know this area. Yes? This area is 95% or 0.95. If this area is 0.95, what's the z-score that separates 95 from 5? 1.645. Right? So when we're talking about a rejection region, in this setup, we're doing this. The easy way to look at it is this. I'm just going to... That's a... Where are you finding the rejection region? The rejection region is on the right. It's a right tail. So let's try this one. If I have this, where's the rejection region? Well, it's on the left. The alpha is still 0.05, and this number is 1.645 negative. Right? So this was right tail, this is left tail. What's the last chance? The last one says, hey, where's the rejection region? Again, what are we looking for? We're looking for a place on the distribution where the sample is very far from the population. Right? We are assuming this. This is our assumption. This is true. 50% is true. Right? In this case, if we find something, if our sample produces something way bigger than 50%, we're saying that this assumption is wrong. In this case, if our sample produces something smaller, way smaller than 50%, we say the population is wrong. Okay.
What about the third one?
Oh, we're getting there. We're getting there. Cliffhangers. Trying to figure out a good example. Let's look at an example. Let's look at a claim, most students pass statistics. Yes? Mostly in positive. Which means that in our case, P is greater than 0.5. Which is this one. Yes?
Yeah.
So the opposite is at most 50% people pass statistics. So far, so good. H sub 0. Now, which claim or the opposite are we going to go after? It doesn't matter. We're going to go after H0, H sub 0, right? We're going to test this. I'm assuming the assumption is 50% of the people will pass statistics. That's the assumption, right? I tell you this grand scheme, you believe me. 50% pass statistics. So you start asking random people that took statistics, and you get some data, right? If your data says, hey, most people didn't pass statistics, most people that you interviewed didn't pass statistics, do you trust my claim or do you trust your sample? You trust your sample, right? Which means that there are two things wrong. If your sample is very different from my claim, your sample is taken from my population, right? I state my population is split 50-50, right? You take a sample, which means that your sample should be about 50-50. Maybe 48-52, maybe 52-48, right? It should be somewhere there, right? Because it's a normal distribution, so most of the data should be here. So if you pick a sample at random, that sample should be very close to the population. Yes? So far, so good. Good. You take a sample that is very different than the population. There are two things that could have gone screwed up. One is your sample wasn't random. You asked the people that are picketing outside my office claiming that they passed the exam where I failed them. And you ask them, and that's your sample. Sample is not random, right? You picked only the people that actually hate me for taking statistics. So that's problem number one. But let's say you did take a random sample. What's the other possibility? Well, the other possibility that by random chance, you picked people that were just unluckily failing statistics and hating me for failing statistics, right? But the chances of that are very, very small. For example, in this case, you're almost 6 standard deviations away from the population, right? Which means that either you got really, really unlucky, which rarely happens, right? Or my statement about the population is wrong. You have two pieces of information and they should be relatively close. Your sample and your population should be relatively close. You took a sample and end up over here. Either you took the worst possible sample, either not random or you just got really, really unlucky, and almost 6 sigma, it's 3 in a billion chance, or my statement about population is wrong. If my statement about the population is wrong, if this assumption is wrong, we're going to reject it, right? Rare event rule says that if under a certain assumption, chances of an event happening are really, really small, aka your chances of picking a sample that is way out there is really, really small, this assumption is probably wrong. If this assumption is wrong, then H sub 1 is right. Oh my God, so many blank stares. All right, let's finish this and let's try this again and see how it goes. All right, if we have P not equal to 5, then means that we could be less or more. So we're looking at this region and this region. Problem now turns out that our alpha refers to both of those. If our alpha refers to both of those, then this and this space, right, because they're symmetric, they're both alpha over 2. Which means how big are they?
0.5. Oh, point. I'm sorry.
Yes? And we can find the critical values for those. Right? This one comes out to be negative 1.96, and this one comes out to be just 1.96. Okay. I'm going to leave this up. I'm going to just scroll it. Let's take this one out.
So we just have to figure out what the rejection element is on 3 then. Where we took it from.
Sorry?
So
If it's not equal, right? If I state, hey, your grade is going to be a B, definitely a B, right? Then if you want to reject that claim, you need to get an A or a C. C or an A, right? If I take a grade is going to be at least a B, then you need to get a B minus, and right, to prove them wrong. If I tell you your grade will be at most a B, you get a B plus, my statement is invalid, right? Okay. Let's do this. We talked about test statistics, right? I give you the list of those. Let's look at the test. I'm going to put them up again. So test statistics. We have the following test statistics. For proportion, we deal with Z p hat minus P divided by PQ square root. For mean, we have two choices. For mean, we have two choices, Z and we've seen both of those, right? We use T if sigma is unknown. Yes, we did this at some point. I showed you those. Okay. Yes? Okay, good. At least one nod every now and then would be great. Yeah. Yes! Excellent. A little late, but. So, the example we did is we did a survey, and the survey said out of 706 company 706 CEOs, 61% were male. Right, we called 706 companies. We got them to the HR department to tell us who is the CEO. We got statistics. So this is a survey that we did. The claim we're hearing is that most CEOs are male. That's the claim. Most CEOs are male. All right. Last class we said, and at the beginning of this class we said, that we deal with claims like this by stating the claim and the opposite symbolically. So the claim is what? Well, P is bigger than 50%. Okay? The opposite of this is no. P is smaller equal to 0.5. We're talking about the opposite, right? Now, we have to pick which one is the null hypothesis. The null hypothesis has an equal sign in it. So between those two, the opposite has the equal sign, right? So this would be our null hypothesis. If this is our null hypothesis, then the alternative hypothesis, H sub 1, which is the opposite of the null hypothesis, is the other statement. So far, yes. Now we're going to restate those two hypotheses. The null hypothesis is going to be defined as P, and now we simplify this to just equal 5, and the alternative hypothesis is still the same. So far, so good. Okay. So we got the first part. Part 2 is we need a what? We need a test statistic, right? What is a test statistics? Is something we get out of the sample to check if that sample is random part of the population, right? If it's way out there that either wasn't random or the population was wrong. So in our case, the test statistics is that. Right, for proportion. So that's our test statistic. So we plug in our numbers. Well, what our numbers are? What's P hat? Points? Well, we got it right here. We got it straight from the survey. What's P? 0.5. We assume the population is halfway divided. That's our assumption, right? The statement is we assume null hypothesis is true, and then we poke holes into it, right? Do those genes make me look fat? The assumption is yes, your statement is true, they make you look fat, and then you try poke holing it with, honey, you look great, right? You look fantastic. You start poking holes in the claim. So this is, what's Q? Opposite of P, right? It's 2.5. And then N, 706. This is how many times we asked the question if the CEO was male or not. So if we plug in all of this in here, our Z turns out to be now we're going to not round the fraction, and we're going to come out to be 5.84. I think I rounded it earlier than most. If you just plug it in straight in calculator, you should get 5.83, which is about the same thing. Okay. And now, the question I left you with in the last class was, is this unusual enough? Right? Is this sample unusual enough? Right? You buy a bag of red M&Ms, you pull out one green M&M. Okay, happened. You pull up a handful of M&Ms and all of them are green, or primarily green. Are you wondering if the assumption that the bag was full of red M&Ms is true? Yes? No, never happened to you. Okay, you go to a restaurant, you get a boneless fillet of fish. You get one little bone, happens, right? Excellent. You start pulling those 2-inch long suckers out of that fillet. Are you wondering if maybe there's false advertisement about being boneless? I have luck. I can pull up a piece of bone this big from a fish stick, so I'm very lucky, right? But this is the question, right? We pulled a sample. Is this unusual enough to invalidate our claim, right? Now, is this unusual enough depends on one more thing.
Rejection value.
How big is the rejection region? How significant do we want to be? How much space are we allowing ourselves to occupy? And that depends on our alpha. Right? If in this case we use alpha to be 5%, if we use this alpha, we look at all those. Which one of those, first of all, we're going to deal with? Well, we're going to have a right tail test. Yes? Right? We're going to have a right tail test. So out of all of those, it's this one. Right? That's the same. Right? And where is 5.84? 5.84 5.84 is somewhere here. Yes? So 5.84 is here. It's way into the rejection region, which means what? Which means that we're going to reject H sub 0. Okay, so we are rejecting H sub 0. So we are rejecting H sub 0, which means that we are rejecting the opposite. Yes?
Yeah.
This and this is, that's H sub 0. So we're rejecting the opposite. If we are rejecting the opposite, then this is true. Ta-dam. We have enough evidence to show that most CEOs are male.
Yeah, 61%, that's the bigger half.
Well, yeah, but this is a sample, right? The whole idea is this is a sample. You could unluckily just call to a bunch of chauvinistic companies, right? Just, I'm saying that the chances of that are very slim for the margin of error I'm allowing myself to have, for the margin, right, for the significance of it. Maybe? All right. How about we do a little theory and then we do another example? Okay. So let's do a little theory first. So we have three types of tests. Three types of tests, and they're all determined by H sub 1. So depending on what your set sub 1 is as a statement, we have one of three tests. We have the left tail, if right, if H sub 1 has smaller than sign, we're looking at the left tail test. That's this one. We have a right tail if H sub 1 has a greater sign. And then we have a two tail if H sub 1 has an equality sign. Okay. Let's look at an example. Let's do this one. Which examples they give? Example. So we have an advertisement, so an ad stating that a hybrid car has mean gas mileage of 50 miles per gallon. Right, so we have an ad saying that. You take a random sample of 30 hybrids. And what? Let's go with 50. Let's go with 50. You find that the average is 47 miles per gallon with a standard deviation of 5.5 miles per gallon. So an ad says hybrid cars have gas mileage of 50 miles per gallon. That's the ad. You take a random sample of 50 hybrid cars, you find that the average is 47 miles per gallon with a standard deviation of 5.5 miles per gallon. Okay. So the question is, at a significance of alpha equal to 0.005, is there enough at a significance level of 5%, is there enough evidence to reject the claim?
Is it time to draw a picture?
Oh, let's go down. First step is we need to state the claim and the opposite.
Oh yeah, H1,
Yes. So step one is claim. What is the claim? Symbolically.
H equals, or P equals,
It's 50. Oh, yeah, 50, oh.
yeah, is it P equals 50? Or is plus 5?
One of those days you're going to have to explain to me how this is P.
Oh, then 47.
Yeah,
The mean is 50. No P. Unless you need to P, then right. So what's the opposite?
Less than.
Could be more than, right? If I say it's 50 and I'm stomping my foot, it's 50, and you go like, no, we got 75. That's not 50. All right. Which one of those would be H sub 0? Which one would be the null hypothesis? Because we get to test only one of them, right? So which one is it? The top one, yes. So we have this. So we have to rewrite it. So we're going to rewrite it. All right. So what's next? What other information do we have?
Standard deviation.
So we have, let's put it over here. We have
Are you plugging it in?
well, we can plug in, we can draw a picture. I mean, there's a bunch of choices. If we draw a picture, what are we looking at? Left to tail. Well, this is alpha over 2. And this is alpha over 2. So what are critical values?
And 5.
1.960.
Oh,
Right? we take the z-score table and we find those values. Right. And this is our reject region, and this is our reject region. And this in the middle is the fail to reject. Why is the middle one fail to reject? Again, because if our sample ends up being very close to the population, then our assumption could be true, right? We only get rejected if our sample states that what we got is outlandishly different, and outlandishly there's a quotation marks, different than the population we assume, right? Because our assumption becomes this. This becomes our assumption. This is true. Okay, so how do we test it? There's that. Okay. Now here's the little nugget. How big is this sample? 50. It's a big sample, right? Central limit theorem says that if the sample is bigger than 30, right, use the z-score. We reserve the t-score mostly for what? For small samples we don't know the standard deviation of, right? If we take a large sample, the standard deviation of that sample is somewhat reflective of the population. So this really, one could say that this is going to be about the z, because this s is going to s over square root of n is going to behave like the standard deviation of the sample means, right? If we take a big enough sample, t-score turns into a z-score. So this is just a little nugget you guys might see in other textbooks. All right, so let's plug it in. What do we get? Well, we get our z-score is about 47 minus 50. Why for mu is 50? Why? Because that's the assumption. Again, we are assuming it's 50, right? So it's 47 minus 50 divided by 5.5 divided by square root of 50. Okay? We assume this 50, our sample is 50. And what do we get? Negative 3.85. That's what you got? 8.6. Well, if it's above, the next digit is above 8.6. Okay. Where is negative 3.86? Negative 3.86 is right here. So, what's our answer?
It rejects it, right?
Mm-hmm. What do we reject?
Claim that the mean is 50.
Exactly. So, the answer is we have enough evidence to reject the claim that mean miles per gallon of a hybrid is 50. And that's hypothesis testing in a nutshell. We're doing this on Wednesday, like the whole Wednesday we're going to be sitting down and doing problems like this. I'm just going to bring a packet and we're going to do this, and then I'm going to show you one more trick. All right. Are we comfortable how we got here? Stumblingly, a little bit up the hill, but right. So again, the idea behind hypothesis testing is, can we look at a test statistics or a sample, look at the significance level, which means allowance on how much, how rare something has to be for us to reject it. Can we look at those things and say our sample says that the population statement is wrong, or our sample is close enough to the population? We don't know. You could have both cases. Which brings us to one more thing. If we have the claim and the opposite, and we have two choices. One is that the claim is the null hypothesis. The other one is if we have the claim and the opposite ends up being the null hypothesis, right? We have those two choices, yes? And then we have two choices. We can reject H sub 0 or not, right? So if we reject H sub 0, the answer is we have evidence to reject the claim. That's how you write the answer. So if the claim is your null hypothesis and you decide to reject H sub 0, we write that we have enough evidence to reject the claim. If you fail to reject H sub 0, the answer you're going to write is we do not have enough evidence to reject the claim. Right? If you fail to reject H sub 0, you just don't have enough evidence to reject. If your opposite, the other scenario is your opposite is H sub 0, then if you reject H sub 0, the answer that you're going to write is have evidence to accept claim as right, or to prove the claim to be right. On the other hand, if you fail to reject, H sub 0, fail to reject H sub 0, then you say do not have enough evidence to accept H sub 0. So we have two choices. If the claim is H sub 0, then we either reject it or don't. If the opposite is H sub 0, we either accept the claim or we fail to accept the claim. We don't have enough evidence. There's four choices. Right? And this should be relatively obvious from the discussion we had earlier. So if your claim is H sub 0, then you reject it or you don't. If your opposite is H sub 0, and your claim is H sub 1, then you can either accept it or not have enough evidence to accept it.